Okay, so at this point, let's start to take a look at the types of numbers that you come across in measurements. And along with that, we'll have a discussion of what are known as significant figures. So the first type of number that you come across are what are known as measured numbers. Measured numbers are the numbers obtained when you measure a quantity such as your height, weight, or temperature. Keep in mind, weight and mass don't mean the same exact thing. A lot of times, mass and weight are sometimes used interchangeably, but they really shouldn't. Weight refers to the gravitational pull on an object, where mass is a measure of the quantity of material an object contains, and they are technically not the same thing. The key idea here is that, sorry, I have to put the pen up. The key idea is that measured numbers are obtained when you use some sort of measuring device. What do I mean when I say measuring device? Something like a ruler, something like a graduated cylinder to measure volume. Again, one other example, something like a thermometer when we measure temperature. So when you use some sort of measuring device to obtain that measurement, that type of number that you get is what is known as a measured number. Now, to write a measured number, you observe the numerical values of marked lines. In other words, you want to interpret exactly what the lines on the instrument represent. You know, if you go back to the example of the graduated cylinder that we have here, this is an example of a 1,000 milliliter graduated cylinder. And each of the lines, if you look at the blow up from between 900 to 1,000, and this would be consistent throughout all parts of the graduated cylinder, each of the lines there represent 10 milliliters. So starting at the line right below 900, let me use the mouse. This line here would represent 900 milliliters. You'd have 910, 920, 930, 940, 950, so forth and so on. Now, a lot of times what happens is that your measurement, where you're measuring, whether it's length, whether it's volume, whether it's temperature, whatever you're measuring, you don't get usually the final part of it on a marked line. You know, if you think about the liquid in the graduated cylinder, a lot of times the meniscus, the bottom of the meniscus, doesn't fall exactly on one of the markings. You know, if you go back to the examples earlier on here, where you have, and they didn't do it here, I think they do it in the next slide, sorry. If you look at the examples here, just to jump ahead for a second, you know, when they're using the ruler, none of the measurements, well, except, sorry, for A and B, both of these measurements do not fall exactly on a marking. So the final number in your measured number is essentially what is known as the estimated number. Okay, so when you obtain a measured number, essentially the final digit of that number is considered to be an estimated value. And that's because of the fact that in the majority of the cases, when you're using the measuring device, what you're measuring doesn't fall exactly on a marking. Now, the question sometimes becomes, what happens if it does fall on a marking? I'll mention about that in the next slide as well. All right, so here are three measurements that are done using a ruler. In the first ruler, the values are only at every centimeter. So 0 centimeters, 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeters. And then in this case, the wooden plank falls somewhere between 4 and 5 centimeters. So whoever's coming in and reading the value here is saying that they believe that the wooden plank is falling somewhere exactly between 4 and 5 centimeters. So that's why they wrote 4.5. But here's the issue. I can come in and I could say, wait a minute, to me, the wooden plank looks closer to 4 than it does to 5. And I would say, you know what? It looks like it's close to the middle, but I think it's closer to 4 than to 5. So I might write 4.4 centimeters. Somebody else might come in and they might say, you know what? You're both wrong. To me, that looks closer to 5 than to 4. And therefore, I'm going to write my value as 4.6 centimeters. It doesn't make any sense to go further from there, because every time we sort of like go further, we're just estimating more and more and more and more, so to speak. The question then becomes, who's correct? And the reality of the answer is, I'd hope you say that I'm correct, but the reality of the answer is we don't know who's correct, because each one of us in that final digit is doing what? We're estimating what that final digit is. Same thing in B. Now B, there are more markings between each of the centimeters. So here, if you take a look at the number of markings, you have to the tenths. So like between 4 and 5, you have 4.1, 4.2, 4.3, 4.4, 4.5. So here, it looks like it's between 4.5 and 4.6. So whoever's reading the value here is saying it looks to them like it's right in between 4.5 and 4.6. And therefore, it would be 4.55 centimeters. And again, we can make an argument. I can come in and say it's closer to 4.5. So I would write 4.52. And somebody else could come in and they could say it's closer to 4.6. So they might write 4.57. Again, we're all estimating. We don't know exactly who's correct. On C here, now the measurement falls right on a marking. So if the measurement falls right on a marking, the way that we indicate that to the reader is we give a 0 as the final digit of that number. So notice that we didn't just write 3 centimeters here, we wrote down 3.0 centimeters. And that would tell whoever's reading this that they believe that the marking, that the wooden stick here, whatever they were measuring, fell exactly at 3 centimeters, 3.0. So if you feel like it falls right on a marking, you would write a 0 as the estimated figure. For example, just to go back to letter B, if we felt that the wooden plank fell at exactly 4.5, then we would write that as 4.50. And that would tell the reader that you felt that exactly the wooden plank fell at that 4.5 value.